Good morning all. This is Uttam sir. Welcome back to you again. Today I am going to solve integration of square root of tan x dx. This is one of the very important questions. Let t is equal to square root of tan x. This is square root functions. Then we try to remove the square root. Then it is necessary to squaring on both the sides. T square equal to tan x. Then we observe here function with respect to x. Then it is necessary to find derivative on both the sides. Now I am applying derivative on both the sides. Then we will get 2t into dt by dx equal to sec square x. Now we can just multiply sec square x into dx is equal to d dt. Then dx is equal to 2t dt divided by sec square x. Now we have integration of square root of tan x dx. So this is can be written as integration of, already we have taken square root of tan x is equal to t, then you write on here t. Then dx is equal to t dt divided by sec square c. We must observe we have already function with respect to dt. Then it is necessary to convert the x function to the t functions. Then integration of this is 2t square divided by, we know that sec square x minus tan square x is equal to 1. Then sec square x is equal to 1 plus tan square x. Already we have dt. Again integration of 2t square by 1 plus, is x form is still no x form is there, so it is necessary to convert t functions. So tan square x is equal to what becomes tan square squaring again, then we get t fourth. Then you can write 1 plus tan square x is equal to t fourth dt. Perfect. Till now I hope everybody clear. So now again integration of 2t square is divided into two parts. T square plus 1 plus t square minus 1 whole divided by 1 plus t4 dt. Just I have adjusted here plus 1 and minus 1. If you consider, then you will get 7.2t square. Okay. So now it is divided two parts. One is integral, one part integral of the integrations t square plus 1 by 1 plus t4 dt plus integration of t square minus 1 by 1 plus t4 dt. Now we got two integral parts. One is this one and another one t square minus 1 by this one. Okay. So now individually we need to solve. Now we observe students in both numerator and denominator having even powers. Then one trick we have to remember, if your numerator having positive, then we try to form the denominator in a minus b whole square form. In this case, your numerator having negative sign, then we try to form the denominator in a plus b whole square. Okay. So first step is here, we are observing both are having squaring, that means even function. Then dividing t square in both numerator and denominators. Then you can get integration of 1 plus 1 by t square divided by 1 by t square plus t square dt. What I did? I did only t square dividing both numerator and denominators. Okay, plus integration of same procedures, dividing t square into both numerator and denominator. Then we can get 1 minus 1 by t square all divided by 1 by t square plus t square dt. Now we have separated the both integral. Now what we'll do, the next is your, what I said you, if you have numerator having positive, then we try to form it is a minus b whole square. Then we write for this part, first this part I am going to solve this part, and after that I am going to move to second part. Then numerator is the constant, that means we have to prove 1 plus 1 by t square divided by, we try to arrange this as a minus b whole square. That means a square plus b square minus 2ab, 2 into 1 by t into t. Then what extra we have added? Minus 2. Then let's also write plus 2 dt. So similarly for second parts, plus again integration of 1 minus 1 by t square all divided by again a square plus b square. What I said to you, if your head is having negative, then you try to form this as a plus b whole square. Then a square plus b square, that term is there. Then plus 2 into 1 by t into t. That means we added plus 2 extra. Then definitely we can write here minus 2 dt. I hope everyone till the procedure are correct. Okay. Then now next, 1 plus 1 by t square all divided by, this is up to this term is your a minus b whole square. That means we can write t a minus 1 by t, a minus b whole square. Then plus 2 dt plus 1 minus 1 by t square whole divided by this is a plus b whole square. That means we can write t plus 1 by t whole square. Till now this, up to this is your a plus b whole square. Then we have minus 2 dt. Next, our job need to solve particularly for integral first part and also second part. Give chances to complete my solutions. Okay, so now we can take let u is equal to t minus 1 by t for integral first parts. Now we are observing the function with respect to t. Then we have to find the derivative on both the sides with respect to t. Then we can get du by dt equal to dy dt of t is 0, 1. Then we know minus, first you can write minus. Then we have formula dy dx of 1 by x is equal to minus 1 by x square. We have the formula. Then that minus and this minus become plus. Then you will get 1 by t square. Now you can just multiply 1 plus 1 by t square dt is equal to du. Similarly, we can solve for the second parts. We can solve for your second parts. Again, you can take let b is equal to, for second part integral, b is equal to t plus 1 by t. Again, you have to find the derivative of both the sides. Then dv by dt equal to, this is 1, then minus 1 by t square. Then again cross multiply, 1 minus 1 by t square, dt is equal to dv. Then continue. Everybody have the great passes to look my video. So now continue to journey. We'll start again from here. Integration from. We have 1 plus 1 by t square dt. 1 plus 1 by t square dt. What we can write? We can write du. Very important points. For these terms, we can write what? Du. Then we have already taken t minus 1 by t is equal to u. Then this is becomes your u square plus 2. 2 also you can write root 2 whole square. Root 2 whole square? 2 only. Okay. And plus integration of, please observe again, t 1 minus 1 by t square dt equal to what? dv. That means in this class we can write what? dv divided by t plus 1 by t is equal to v. Then we can write this is v square minus 2, again we can write root 2 whole square. I hope everybody have clear. Okay, next. Now we can solve individually integration of integral part 1, and also you have to find the integration of second part integral. So this is direct formula is there. We know integration of dx divided by 1 plus x square equal to tan inverse x. But in this place, dx by suppose a square plus x square is there, then we have the formula 1 by a tan inverse x by a plus c. Everybody you have clear. According to that formula, we can write 1 by a. Okay, so now we got this formula. Then now we can write du by the same formula. This formula we can apply 1 by a. Therefore, root 2 1 by a. Tan inverse x. What is the x here? U by a, it means root 2. Okay, plus this is, we have the formula dx divided by x square minus a square. Can anyone? The formula is what? 1 by 2a log mod of x minus a by x plus a. That formula we can apply here. The 1 by 2a, 1 by 2 into a means root 2 log mod of modulus functions, mod of, because why it is modulus? Log function, we know everybody, log x, the domain of the log function is always r plus positive real number. That means always log function is must be a positive. That's why we are writing modulus. Okay. The log x minus a, that means b minus a for root 2 x minus a by x plus a, that means b plus root 2. Integral has removed, then we write plus c. So now 1 by root 2 tan inverse u for what you have taken earlier, u for t minus 1 by t. Then you just paste here t minus 1 by t. For u I have mentioned t minus 1 by t whole divided by root 2. Okay, these all are angles because tan inverse x, in place of the x, all term is there. Plus 1 by 2 root 2 log. Now again you can understand here. So v is equal to what we have taken earlier. V is equal to t plus 1 by t. Then you can write here t plus 1 by t, then minus root 2 whole divided by similarly 3 plus 1 by t plus root 2. Mod has closed. Okay. We must write c plus c because it is a indefinite integrals. Okay. Plus c. Now just simplify. We need to simplify. So 1 by root 2 tan inverse t square minus 1 by root 2 t plus 1 by 2 root 2 log t square plus 1 minus root 2t whole divided by t square plus 1 plus root 2 t. Nothing else done, only for simplify. Now, one value to tan inverse. Please go back to my initial first steps. First steps I have considered, I have taken for the questions what? Integration of root tan x dx. These are our questions, was it? We have considered earlier, put t is equal to what we have taken? We had already taken t is equal to root tan x. Then t square is equal to tan x. That means in this case, because our initial function was with respect to dx, then it is necessary to all the t and v or u, whatever you have taken, that must be converted into the x function, because our initial function was there with respect to x. Then t square is equal to, you can write what? Tan x minus 1 divided by root 2 t for root tan x. That means we can write single under the root 2 tan x under square root 2 tan x, because root 2 and t means into root tan x. That means we can write under 2 tan x. Okay, plus 1 by 2 root 2, again log t square means tan x plus 1 minus same t for root tan x. So underscore root what? 2 t for tan x. Okay, then divided by t square tan x plus 1 plus square root over 2 and t for your tan x. Then plus is there, big C, capital C. Okay. Then I hope you are clear. T square already I have mentioned here tan x. Then minus 1 by root square root over t tan x plus 1 by 2 root 2 log. Then I mentioned. Okay. Thank you very much for your great patience to observe my video. And thank you. So time to time, definitely I'll give you very, very important questions for your board examinations. Thank you very much. Bye.